as you can see. Technology profiles was something that kind of came along, and its genesis was basically at an AT&T lockdown meeting at the beginning of 2018, actually well before SEBA made its appearance. So one of the issues at the time that was being discussed was basically how to make the Volta Core agnostic to any particular type of access technology, and actually maintain an open flow abstraction, a logical switch abstraction, where this logical device has NNI interfaces and UNI interfaces for the subscriber side. I want to thank the ONF for allowing me to steal some of their slides too. I saw a few early ones from Shad that I want to steal as well. If we kind of take a look in detail at Volta, we see that it has this logical switch abstraction. Again, each of the uniports, as they're discovered, are added as interfaces to this logical switch. And the OLT itself has NNI ports that are added. One thing that the access industry has is many standards bodies and many standard documents. And especially if you look at PON, PON has been around for many years. So APON, BPON, GPON, NGPON, NGPON2. So there are lots of requirements that have been specified around the operation. As well as if we look at Broadband Forum, there's also many standard documents around how access systems work, like TR-101, ATM to Ethernet, TR-156, GPON to Ethernet, TR-280 defining enhanced QoS models. So what we found was initially, after adding a Broadband Forum WT385 model to control some of the PON, let's say, transmission convergence layer attributes like ALAC IDs, GEM ports, ONU IDs, it became obvious that it's going to become very burdensome on the Volta Core to be able to support all different technologies that we're interested in, because these OLTs may not just be PON based; they may be EPON. So you have to look at the DOCSIS standards. So DPOE. So there's lots of different models, object models that have been defined, Yang models. How do we manage these devices as simple logical switches with northbound and southbound interfaces, and allow OpenFlow to connect up those interfaces, defining match action rules on the UNI interface, and similarly on the NNI interface, and then apply something that's specific to the technology, the access technology that's being deployed. So out of that early lockdown meeting we had at AT&T with all the operators and vendors, we kind of came up with an idea of using what's called technology profiles. The technology profiles, basically, let's move on to this one. So the technology profiles kind of define technology-specific attributes for a given service, and it's used in combination with OpenFlow. So OpenFlow can define, as I said, the match action rules on the interfaces. OpenFlow also has the concept of meters, so I can define upstream and downstream QoS parameters. And I can combine that with my technology-specific attributes to create a service that has all the capabilities and features that the operators are looking for. So I can define a best effort service with a peak information rate, or I can define a service like VoIP with say an expedited forwarding service that has committed information rate. Combining technology profiles and what OpenFlow already has allows us to create a fully well-defined service. Oops, can I go back here? So the idea is that OpenFlow comes down into Volther and defines the match action rules and defines the meter band information. And it also has a reference to a technology profile. Now, the core itself doesn't need to know anything about the technology profile, because technology profiles are just basically downloaded into the KV store, and they're basically available for access by the adapters. The adapters themselves can fully decode and understand what's in a technology profile. So the core passes down the OpenFlow flow definition and meter band data, and the adapters themselves go and grab the technology profile that's referenced in the OpenFlow messages. Then basically that set of information is combined to both configure the OLT in terms of queuing, scheduling, both upstream and downstream, and also to define the OMCI messages that Chip was just describing to send down to the ONU itself over the OMCI. So if you look at kind of an example of a technology profile, this one is for XGS PON. Obviously, the focus has been on XGS PON. And we can see that we've tried to combine actually several standards into the technology profile itself to define attributes that we can use to define the service flow in the context of XGS PON. In addition here, so there's some identifiers for the technology profile, a version number, a profile ID, an OpenFlow table ID, which is the reference that this OpenFlow message has. There's a common instance control that kind of combines some of the TR-156 and TR-280 service model information. So I can do, if I want a traditional TR-156 4+1 service model, so I can define 4 classes of service. Each class of service has its own single gem port. So each class of services is applied to the ONU as a whole, right? So basically every UNI interface that has a best effort service uses the same TCON in that case. In the case of TR-280 or where I want to find a service that is unique to a subscriber, it has its own TCON, ALAC ID, and 1 or more gem ports. This allows me to control the creation of multiple gem ports with a single TCON and its applicability to a single UNI interface. The other parts of the technology profile define an upstream scheduler, a downstream scheduler. Obviously, in the case of PON, the upstream scheduler is related to the TCON scheduling. And there are some specifics around DBA that are applied here. So I can do, instead of scheduling based on bandwidth and the type of service, I can define it as a priority and wait type scheduling, or I can override a field that's in the upstream scheduler for the additional bandwidth. So normally I can imply what kind of additional bandwidth the service needs from the parameters, but I could say I could have either no additional bandwidth for this service, or non-assured, or best effort. Auto just means I'm just going to use what's implied from the service definition. So there's also a queue scheduling policy that allows me to, if I have more than a single gem port, I can apply, priority scheduling or weighted round robin scheduling, or a hybrid of both. and again, if you, we'll see in a little while, I think I have a picture of the AT&T open OMCI specification for a high-speed internet service, and you'll see that there's, you know, in general, there's 4 gem ports with a hybrid type scheduling. We'll talk about that. And for each gem, I can define, you know, what p-bits get mapped to that particular gem for that service, whether I have encryption, discard policies, queue sizes, weight, etc. So basically, this is a kind of a distillation of everything I can specify applicable to a service from the standards, and this is then associated with an open flow definition for a particular subscriber port. Open flow defines, again, the match action rules on ingress, and the mapping to a particular gem port, in this case, is via p-bit map. Let's see. And if we look at a representation of an OLT system with an OLT here on the right and ONUs on the left here. So if we say the OLT has an MP switch component and a MAC component that has a DBA engine for scheduling upstream, and we have our ONUs with a UNI interface and mapping, match action rules on ingress, then a p-bit mapper to gem ports to TCONs. We can see that the technology profile can be applied at different positions in the upstream and downstream of this aggregate system here, along with the open flow definitions for the match action rules and the bandwidth profiles. So in this case, I have 4 gem ports and a p-bit map to each of those particular gem ports, and a scheduling policy applied at the TCON level in the upstream direction. Similarly, in the downstream direction, I can define 4 queues with a scheduler and a scheduling policy applied to those downstream queues, and also the bandwidth policy as well. This is a bit of an eye chart, but so this is basically the MEs required for a high-speed internet service from the AT&T's Open OMCI specification. So over here we see I have a single TCON, I have 4 priority queues, 4 gem ports, and I have my p-bit mapper. So all this information can come from the technology profile. Pretty much all the information on this side of the screen here comes from the open flow message with the match action rules. Okay. So that was kind of discussing XGS PON. I mean, if we look at other types of equipment that could be managed by Volta, we see that I could have a G.fast DPU adapter, and I can define a technology profile that's specific to the G.fast DPU adapter, and define open flow rules and bandwidth profiles that could apply to that adapter as well, and the UNI interfaces that subtend from the G.fast DPU. So in this case, and again, this hasn't got followed through with all the implementation and details that the XGS technology profile has. But in this case, we could have a typical TR-165 model vector of profiles for the technology profile itself. So basically, all these files defining the behavior of a G.fast UNI interface could be defined as a technology profile. And if all these are the same, you can use the same technology profile for all the UNI ports. So if you could actually put those 2 models together, and if Volta's managing the DPU via some in-band channel, say, I can define flows and the technology profile for the gigafast UNI on the DPU. I can either have an integrated ONU or basically an Ethernet interface from the DPU to the UNI of an ONU. And then the aggregate flow from the DPU can be defined as a service from that ONU interface on the PON. So that's just a way to connect up two different types of devices that are managed from the perspective of just being a logical switch abstraction. And I add my open flow rules and bandwidth profiles, and I can define a technology profile that addresses the technology specifics of that particular device. And EPON is another example, the same thing here. So I could have an EPON OLT or virtual CMTS and virtual cable modems. And again, do the same thing. I define open flow rules, meter bands, a technology profile specific to EPON. And I have my Ethernet OM messages provisioning the DONU, and just control messages, gRPC messages, provisioning the EPON OLT. And now I'm able to manage these devices via this logical switch abstraction plus open flow plus technology profile. Example of this one, I may have gone a little bit overboard on the upstream scheduler part, but this can be probably in a real example. This would be much simpler because usually we have the equivalent of our TCOM, which is in EPON is an LLID, and typically there's only a single queue basically for that flow. So basically we have the same model here. It's the upstream scheduler, downstream scheduler, and parameters around, in this case, a queue versus a gem. Questions? Not sure how I'm doing on time here. Okay, good.
Tom Toffee?
Thanks so much. This was great. Two questions. One is, what's the delay budget for DBA? What's the best delay that you can get on DBA engines if you do an optimization around it and all of that? And the second one is, any of these profiles that you do, I guess technology profiles, etc., is there any chance you can also carry timing with you? Like if you have toggle timing that you want to basically carry over the single phase and all of that, is there that opportunity?
So the technology profile is basically giving you that the technology specific part of the service that you can't configure through OpenFlow, right? So I mean things like the latency, there's some typically there's optimizations made around how fast you're polling ALEC IDs that have not sent data recently. So there's kind of optimizations around that, and it's up to the individual chip vendors as to what optimizations they have. I mean, probably typically you might want to shoot for like say a millisecond or something like that. Maybe less for the XGS PON, but. So those optimizations need to be figured out in terms of how you configure the PON interface itself.
I think what we're trying to do with the technology profiles is be somewhat vendor agnostic towards the configuration of XGS. In AT&T's view, you might have the 4Q model that was displayed on there. That might be a residential service that you're going to define in technology profile. You would want that to be able to be put on any boxes, anybody's box. So we're defining those queues, those gem ports, those service parameters and definitions. You might then say, oh, but my business services is not using a residential model. So I might have a business service model that is a different technology profile that is 8 queues, strict priority of what. So I might have a business service that does that. In terms of how the DBA is going to operate, that is not today defined in the technology profiles and would be very specific to the OLT's implementation. Now, if a specific OLT had a specific set of implementation that this is the way my DBA works and this is how it can be tuned and these are things, that would be something that might need a different type of profile. You might have a different set of configuration profiles. We've talked about configuration profiles where, you know, I can take my DBA down to this. That would be a specific implementation of a vendor's kind of specific configuration. That would be a different type of profile that we've talked about having. Do I want to turn FEC on or do I want to turn FEC off? Do I want to do different kinds of configurations there? It would be a little bit different.
You want to carry timing? Is that independent of DBA?
It's not currently in these technology profiles. That's not there. I mean, right now we're really talking about gem ports and queues and priorities and pivot mappings and those kinds of things. But as you know, as vendors differentiate themselves, there may very well be different types of profiles that we would want to create.
And I think you know, the entity is developing the CODBA framework also. Eventually, I think that part of the implementation maybe get integrated into the whole VODA framework. So I think Tom is thinking about front hall. So that's definitely something we'll further explore. You know, I'm taking a little bit more time from that because we squeeze in the original plan, only 3 talks, but we have 4 talks today. Any other question anybody want to ask? I welcome you to join our community. I think the community has been very, very active. And again, so the 2.0 release mid of January, and then the 2.1 right now will be additional 3 sprint scheduled for the 2.1 release. And if you have not met Julie Lawrenson, she's sitting over there. She's the Scrum lady. So she's done a wonderful job here. And I thank all the technical lead here. And thank you for your involvement. And then we would like to have more devices being served by VODA. Okay, thanks.